I will travel where no man has dared to go.
The accepted laws of physics break down.
Boundary between the known universe and a place beyond the reach of science.
Oh, hoy hoy, physics students. Okay, here is the explanation of how we are going to handle a problem that at first seems complex because there are multiple things happening and it's going up a hill, but if you just keep thinking about balancing out forces and forces that oppose each other, it's really not that hard of a problem to get through. So the first thing we should do is that we should read the problem. Paul is pushing the couch up the ramp with a moving truck with a constant velocity. Okay, so constant velocity. This is pretty important to understand because if we have a constant velocity, then it means that our F net, and forgive me, I'm just getting used to a writing pad right now, it's going to be equal to 0 newtons. Okay, so we also know that when we get to our coefficient of friction that we're going to be talking about kinetic friction because he's already moving it. Okay, so we just have to make sure the actual units balance themselves out. So as always, let's go ahead and let's start by working with the information that we know. So in this case, we know that the actual angle, okay, so he's using 241 newtons that we see here, and the 241 newtons is directly to the right, so it's at 0 degrees. So that's going to be important when we talk about our theta. And here it shows me right away that I have a theta that is equal to 21.5 degrees. So the mass of the couch is 36.3 kilograms. So that means directly down, okay, I'm going to have my force of gravity. It's pointing me directly down. And my force of gravity, or my weight, will be equal to this 36.3 times 9.8. Okay, so gravity. So when I do that, I take 36.3 times 9.8, and I come out with a total of 355.74 newtons. So there's its weight. Okay. So the next thing I want to do now is I want to go ahead and start figuring out my calculations in accordance to my y. Okay, so my y right away will be an angle. So if I do my first FGY, all I'm going to do is take my 355.74 times the cosine of 21.5. Right, and when I do that, I will see that I will have a force that points directly down. This is what's making all the contact with the couch. So this is my F, G, Y. And when I do that calculation, I come up with an FGY of 331 newtons. Okay. Now that I'm done with that, I know that there's also another opposing force because the couch is not flying. So my force normal is going to be equal to 331 newtons. Now, because the way we're doing these problems, do not worry about vectors. Okay, just you have to make sense of it as you do your drawing. That's what's important. So you don't have to worry about negatives and positives. So that is what I have so far for my force of gravity just on the couch. I'm only isolating the couch alone. So based on this, I should be able to tell a force that is pulling down on the couch. So if you will, the FGX. So from this point, I'm going to have a force that makes the couch want to go down. That is my FGX. And my FGX will be equal to 130.38 newtons. And of course, I got my FGX by simply taking the 355.74 and multiplying it by the sine of 21.5. It's theta. Okay. I can't calculate it. I don't know the coefficient of friction, so I don't know what's trying to keep this in place. So that's a little difficult for me. But I have essentially calculated all that I could calculate right now for the couch. So now I have to start looking at this force, okay, that he's pushing. So since this force that he's pushing is perpendicular, okay, so it is right across the zero axis, I can actually tell that there'd be a theta in here. And if you look here, there is this triangle that exists right in here, and there actually is my theta. Okay, so I can see that my theta exists right in that area. Cool. So now if I look, I could say, I could see, and then this is my right angle. So that means my theta is also in here. Okay, so now I see this other triangle, and this is how the forces are going to split up. Because we can see this is going to be our y portion of the force, right? And this is going to be our x portion of the force. Because since he's pushing it this way, the force is going to be split up into two different manners because he has to go up this angle. Now, I do know that it's going to draw it a little bit better. And then my blue. So I do know another important thing, and that is going to be that trying to think of what's my adjacent, my opposite, sine, cosine. They can be a little difficult, and then you get mixed up in the operation. But if you use logic right now, if I'm pushing something at an angle of 21.5 degrees, it means it's a pretty shallow angle. Okay, so the majority of the force is going to be going on the x, okay, towards what we would consider the x. And you can see here even scale-wise. So as long as I punch in the numbers, okay, and I take this 241, because that's my hypotenuse right there. So let me go ahead and label all that. So here is my hypotenuse of this triangle. Here is my adjacent angle. Right, and then here's my opposite angle. So however I do sine or cosine, if I look at the values, that should give me the most guidance. Okay, the most guidance to giving myself the correct answer. So in this case, when I go ahead and I hit my cosine or my sine, however you want to calculate it first, but look at the values. So give yourself a second right now to try and figure out the values. So using my sine or my cosine, I see that from this force, okay, I have another that's acting upon the couch, and it's increasing this even more because he's pushing almost the couch down even further. Okay, so from this 241, what I see actually happens here is I should get another, I'm going to call this my F applied and my Y. And when I get this, I will see that I actually get 82.1 newtons. Okay. So I have them come together, and when they come together, they're creating a force that gives me a total. So over here, I can see that once again, it's acting on the same object. I'm going to be doing my F, Y, total. And my Fy total, when I add the two together, should be around 413.1 newtons. Once again, it's simply just like if an object's sitting there, it's not hard to pull it out or pull it away. But if you go ahead and somebody pushes down on the object, even though you're pulling on the X, you can't move it. Okay, it's because they're actually increasing the amount of force, which we'll see in a second, will start to drive up our friction. Okay, so now that I figured that out, I'm going to go ahead and figure out the rest for my X. So I'm going to go ahead and do my trigonometry again. And when I do that, I see that I get, based on that 241, I get an F applied x. I'm going to say my F applied x, and it comes out to be 224 newtons. And just like normal, like when we were doing 2D kinematics, right? This is my hypotenuse. None of the numbers that I just calculated are bigger than it. Correct? And because of my angle, I know my x is a 21.5. So therefore, it's going to be most of my force is going to be, or most of my numbers are going to be on my x coordinate. So now I know that I have an F applied on my x of 224 newtons. Okay, but if you remember before, it's moving at a constant velocity, which means that this has to be 0. So if this has to be 0, the opposing force has to match 224. So all I do is figure out the difference between 130.38 and then 224, and I think about where is that possibly coming from? What else is creating that? And it's what we mentioned before. It's going to be our kinetic friction. So I'm going to think about the difference between the two, and I'll say my force, kinetic friction, and it's the difference between the two. So when I find the difference, I get a kinetic friction that must exist of 93.62. Okay, and then to figure this out, all I'm going to do is simply take my force of kinetic friction, right, and I want to find this ratio between the two because this is being made up by my force total on my y. So it's my force y total. Because if you push down harder on an object, you will actually increase the frictional force. So you're applying a force to it. So once again, since they're made up of the forces, you'll increase the frictional force. So when I divide the 93.62 divided by 413, this number here, I should get a kinetic coefficient of 0.227. And when you do that, you are done with the problem. Okay, you've just figured out what is the coefficient of the kinetic friction. So as long as you treat them as separate problems and use your logic, you guys are all smart enough. You've proved that so far. These problems aren't bad. Just treat them as two separate problems, but think about what's happening. Okay, and then once you separate the two, realize that if you closed your eyes, it would just feel like one giant force and object together. So I hope this helped. Watch it over and over again as you need, and hope you have yourselves a great time.
Their enriched guts across the galaxy. Look up at the night sky. We are part of it. The universe itself exists within us. We are stardust in the highest exalted way, called by the universe, reaching out to the universe. We are stardust in the highest exalted way, reaching out to the universe with these methods and tools of science. We are stardust in the highest exalted way, in the highest, reaching out. The universe itself exists within us. This universe. We are in this universe. The universe is in us. Yes, the universe is in us.